Hello everyone, welcome to lesson 4 on waves. I am F. Nixon presenting. Last week we discussed about properties of waves. There are 4 properties of waves that we looked at. 1. Reflection, refraction, diffraction, and interference. We only looked at reflection of waves. So today we shall look at refraction, diffraction, and interference. They are really very short. Let us look at refraction waves. When a wave travels from one medium to another, which have different densities, it changes direction and speed. When a wave moves from one material to another, which are having different densities, for example, air and water, it moves from air to water, it will change direction and speed. This situation is called refraction of waves. Another example is that if you look at deep water, it is denser than shallow water. When waves move from deep water, which is denser, to shallow water, which is less denser, they also change their direction and speed. So that means refraction also takes place. For example, illustration. The illustration is here. This is deep water and this is shallow water. Remember, this deep water is denser than shallow water. So when these waves which are here move in the deep water, they move in this direction. And as they reach the shallow water, they travel in this direction. So when water waves here move from deep water to shallow water, they change direction and speed. And this is because the waves, the deep water and shallow water, this is because deep water and shallow water have different densities. Okay? Let us look at the things that take place, the changes that occur when water waves move from deep water to shallow water. I have drawn a diagram here. This represents a deep water, this is a deeper water, and then this one is a shallower water. When we generate water ripples in deep water to travel to shallow water, something will happen. You can see that inside the deep water, the distance between a crest and another crest is longer than the distance between a crest and another crest inside shallow water. And since we said the distance between a crest and a crest is wavelength, that means wavelength inside deeper water, this distance here, is longer than the one in the shallow water. So when water waves move from deep water to shallow water, that means wavelength will reduce. Also, when waves move from deep water to shallow water, the speed of the wave also reduces. The speed will also change, okay? Number 3, when waves move from deep water to shallow water, the amplitude also reduces. Remember, we said amplitude is how high a wave has been displaced. For this case of water, how high the water is from the equilibrium position. In an accurate diagram, you'll find that the water displaced from deep water will be higher than the one in shallow water. That means the amplitude is higher in deeper water than in shallower water. So when waves move from a deeper water to a shallow water, the amplitude also reduces. In summary, when water waves travel from deep water to shallow water, the wavelength of the wave reduces, the speed of the wave reduces, the amplitude reduces, but the frequency of the wave remains the same. Remember, we said frequency is how many times the wave makes, how many circles a wave makes in 1 second. So the number of circles that the wave makes in 1 second in deep water and shallow water will remain the same. It will not change. The frequency remains the same. Diffraction of waves. Have you wondered why manufacturers of radios or woofers, they leave a very big hole on the woofer or the radio? It is to make sure that sound which travels from inside the radio or the woofer, when they come out, they should pass through a small opening. Okay? And we call that one diffraction of waves. So diffraction of waves is defined as the spreading of waves around an obstacle when they pass through a gap in the obstacle. You can see this case. This is an obstacle. This stick which is placed inside this water is an obstacle. There is a small hole which has been allowed here to make sure that water waves which are generated here pass through. When you generate water waves in this region, the other side, and they pass through this hole, they will be said to be going under, they will be said to be undergoing through diffraction. Also, the same case happens here. The waves are passing, the water waves are passing through a small hole, which is inside an obstacle. So these waves which are moved here are called the diffracted waves. The ones which have already moved here, they are called the diffracted waves. Even these ones are called diffracted waves. When the gap is very big like this, the waves which emerge here will be almost straight. They will be almost straight waves or plane waves. When the gap is very small, the waves which emerge here will be circular in nature. They will be called circular waves, like in this case. This is an accurate diagram. A large hole or a large gap, the waves will be almost straight. A small gap, the waves will be spreading circular in nature around the obstacle. So in summary, when the gap is very large compared to the size of the waves are diffracted nearly as straight waves. And when the gap is smaller than the wave, the diffracted waves are circular in nature and they are very intense. That means there will be very many here. And that explains why if you allow a small hole on a woofer, the sound that you hear is larger than the original sound because of this. Interference of waves. When I talk and someone talks somewhere, and we talk anyhow, the two sound waves are going to interfere, okay? Also, when you throw a stone here and a stone there at the same time, you'll find that these waves generated here inside the water, one by this stone thrown here and one by the stone thrown there, are going to meet somewhere. And when they meet, they will be said to be interfering. Okay? So interference of waves occurs when waves from two different points meet at the same point and at the same time. When two waves from different points meet at the same point and at the same time, we call that one interference. And the waves must be similar for interference to take place. You cannot have interference of water waves and sound waves. Interference only takes place when there are two similar waves. For example, water waves and water waves are interfering, they are meeting. Or sound waves and sound waves are meeting and they interfering. Now, there is something which takes place under interference, and that takes us to types of interference. One type of interference is called constructive interference. Constructive interference is the type of interference where a crest of one wave meets the crest of the other wave. When a crest meets a crest, you will have a very big crest formed. Crest plus crest gives you a bigger crest. And when a trough meets a trough, it gives you a bigger trough. So when a crest meets a crest or a trough meets a trough, a larger wave is formed, and this is called constructive interference. Destructive interference. When a crest meets a trough, the waves are going to cancel each other. When the crest of one wave meets the trough of the other wave, there will be no wave formed at all, or a smaller wave will be formed. And this is called destructive interference. You can see this from here. This is one wave which is moving like this. This is the other wave moving like this. If you add them together, you'll find that this crest is going to meet this crest to give you a bigger crest. This trough is meeting with this trough to give you a bigger trough. And this is called constructive interference. For destructive interference, you can see a trough is meeting a crest and you have nothing formed. Okay? So constructive interference gives you a larger wave, while destructive interference here gives you a smaller wave or no wave at all. After watching this video, please read the notes which I gave you last week and try to see if you can relate some of these things that I've explained with the notes. In case of any concern, please contact me. My number is 078-665-0095. And you can also put your comment on Google Classroom platform. Our next video is going to be on electromagnetic waves. So after watching this one, tap on it. Thank you so much.